Critical values. So far, we've really talked about our margin of error by being 1, 2, or 3 standard deviations from the mean. And specifically, we've really only looked at 2 standard deviations from the mean, but that's using our 68, 95, 99.7 rule. Note that the most common confidence intervals were 90, 95, and 99. Neither 90 or 99 are exactly 1, 2, or 3 standard deviations from the mean. This means that we actually have to use critical values. In our CFAN example, we use 2 standard errors to give us a 95% confidence interval. The number of standard errors, so that 2, is called the critical value. So however many standard errors you are from your center value, your mean, or your proportion, that's your critical value. Since ours is based on the normal model, we denote it with a Z and an asterisk because that 2 is telling us we're 2 standard errors away, and the number of standard errors we are away is our Z-score. We make sure that we know that it's a critical value because it gets a little asterisk at the top of the Z. For a 95% confidence interval, the precise critical value is actually 1.96. It's not exactly 2 because the normal model is an estimate, so it's approximately 2, but if we want to be more precise, and we do, it's going to be 1.96. So from here on out, we're going to use 1.96 as our critical value for a 95% confidence. What that means is that 95% of the normal model is found within 1.96 standard deviations of the mean. We've been using 2 from our 68, 95, 99.7 rule because it's easy to remember. But for any confidence level, we can find the corresponding critical value from a computer, our calculator, or the Z-score table. Because again, the critical values are just a Z-score. To find the correct values, you have to use the correct cutoffs using the normal model. So for a 90% confidence interval, your critical value is 1.645. For 98%, your critical value is 2.326, and for 99%, it's 2.576. Now, I have here a diagram showing the 90% critical value, and I want to just explain where we get these values from. So here's our normal model. A confidence interval, remember our sample proportion is in the middle. We're saying that's our mean. So our confidence interval is even on both sides. So our confidence interval is right in the middle of the normal model. So if it's in the very middle, that means we have an even percentage on this side and an even percentage on this side. So that means that the leftover percentage over here, if this is 90%, then there would be 5% over here and 5% over here, because we have 10% left over total, and the 90 is in the middle. So that means that to find this Z-score, this cutoff value is actually 0.05. So then to find this cutoff value, the actual percentage is this 5% plus the 90%, or 0.95. It is important to use the correct cutoff values. So the cutoff value is always going to be basically half of what is left over added on. So for 90%, I find the Z-score for the 95% cutoff. To find the critical value for 98%, I would use a cutoff value of 99, and to find the critical value for 99%, I would use a cutoff value of 99.5. Again, I'll explain this a little more in class tomorrow, but let's look at an example for now. Is equal to 0.27. Therefore, Q hat is equal to 0.73, and then I can find my standard error by calculating the square root of 0.27 times 0.73 over 53, because 53 is my sample size. And I can determine that my standard error is equal to 0.061. So I'm going to need my standard error to create these 3 different confidence intervals. So the first confidence interval is a 95% confidence interval for the actual improvement rate. So if I'm going to create a 95% confidence interval, again, a confidence interval is equal to your p hat plus or minus your margin of error. In this case, my p hat is 0.27. My margin of error is going to be my critical value, And for a 95% confident, my critical value is 1.96. So this will be 1.96 times my standard error of 0.061. So this becomes 0.27 plus or minus 0.12, and it gives me a confidence interval of 0.15 to 0.39. The next confidence interval is a 90% confidence interval. For a 90% confidence level, our critical value is 1.645. So this time, my margin of error will be equal to 1.645 times my standard error of 0.061. This gives me a margin of error of 0.10. So then my confidence interval is equal to my sample proportion plus or minus my margin of error. So I get a confidence interval of 0.17 to 0.37. Note when I became less confident, my confidence interval became more narrow and became less wide. Finally, we want a 98% confidence interval. To be 98% confident, I have to have a critical value of 2.326. So my confidence interval will be my sample proportion plus or minus 2.326 times my standard error, because again, this right here is my margin of error. So this becomes 0.27 plus or minus 0.142, which gives me an interval of 0.128 to 0.412. And note when I became more confident, I ended up with a wider interval. Because again, the more confident you are, the wider your interval. The less confident, the more narrow or precise your interval is. This is all I have for today. I hope you have a great night.